Okay, today we're going to be looking at Lab3, and it says in the memory browser window we're going to type in a program that's on page 38. Let's take a look at the program on page 38. There's a number of hex codes that we're going to put in starting at address 100 in hex. So let's go back to Codewarrior and take a look and see how we're going to accomplish this. Okay, so this is what we had from the other day. Now I've renamed Lab 1 to be Lab 2. It's basically the same stuff as we have here. And one of the things we're going to do is we're going to right mouse click here and we're going to say delete. And when we say delete, we have a couple of options here with delete. We can delete just normally, which is what we're going to do, or we can delete to get rid of it entirely, but we're going to keep it around. We're just going to hit OK. And I wanted to show you a couple things because this is again a little bit more with project management. If we've deleted it and it doesn't show up here anymore, we can always go back here and go to import project. And so anything we've deleted but have not gotten rid of off our hard drive, we can go back here. So what we're going to do is we're just going to answer a couple questions. We're going to say browse. We're going to go to our E drive. We're going to go down to workspace. And under workspace we can go to Lab 2 and we can say OK, and then we can say finish. And what it's going to do is once we've done that, over here we've got our Lab 2 brought right back to where we want, and then we can double click on main, we can do all this kind of stuff. So I just wanted to show you that quickly. Next thing we're going to do is we're going to delete it and just know that we can get it back by importing it back. And we're going to create a new project as we've done in the past. So we're going to create Lab 3 today by saying File, New, Bareboard Project, just as we have in the past. And when it comes up with Bareboard Project, we're going to make this Lab 3 to make sure that these things stay in sequence with the labs that we're actually doing. So we're going to just go next and go through the normal startup stuff that we normally do. So it's going to put it under E:\workspace Lab 3. Next, HCS08. We should be fairly quick at this now. GB32, say next, and we want both the simulator and the real deal. Next, and again we want C language, and we're just going to say next. The only thing we're going to ever change out of all these defaults is just minimum startup and then say finish. Once we've done that, it's going to create our project. It's going to take a little time possibly. Here we go. It's doing all this stuff here. And eventually we're going to have Lab 3 up here, and we're going to start at pretty much the same place where we started before. We're going to not really worry too much about main here. We're just going to make sure that we have a binary. Now before you can go to the debugger, even though we're not going to use any of this code right away for the debugger, we still have to compile what's here or else it will not let us go to the debugger. So we're going to do project, build project, and just let it build and create a binary over here, as we'll see. So when it's finished, we should see a binary showing up over here, and when we do, we know that we can indeed go to the debugger and be able to work. So we've got that happening there. So what we're going to do, and there's a couple ways to do this, as we saw. We can either do run, and from run we can go to debug as we saw before here, or what we can do is we can use a little debug and debug as here and go to Codewarrior. Going to select the real hardware out of the two that we've made available to ourselves, and as it creates this, there's a couple other things that you should be aware of. Now the other day we worked with a certain perspective, and let's go back up here again just to take a look, and I'll tell you a little bit about what I've done. Under Window we can say open perspective, and right now the C++ perspective is highlighted, but we can say other. And under other, what I've done is, remember there was a debug perspective. What I've done is I've renamed that to be debug old. The debug new perspective that I had, I've now made debug. And one of the reasons for doing that is because as soon as you start doing anything up here of single stepping or whatever, it's going to default to debug. Even if you got debug new, it'll go to debug. That's why I've taken debug and renamed it to debug old and taken the debug new and saved it over top of debug, so we keep the original. So I just wanted to point that out as we go through this. Now let's go back to what we have to do. We have to put our program into the memory browser, and we're going to put that program in starting at 0x100. I'm just going to bring this up full screen again as we've done in the past. Let's go back up here and take a look. So once we type in 100, the problem that we run into is, again, this stuff is set up not to be set up the way we want. We want 1 byte. We want probably columns. Let's make columns this time 16. And let's make this text is ASCII. Now, what I've done is I've actually put these codes in, and you can put them in yourself, 45, 18, 02, F6, A4, and so on, all the way down to our final thing of 20, F0. Now when you put those in, just make sure that when you're finished, it'll show up. If I just punch in F0, it's green. Make sure after you've typed all these codes, you hit enter so it's actually in there. So that's very, very important. Let's go back and take a look at what we've got. And let's just back out a little bit here and slide over. One of the things that we have to do is check to make sure that these codes that we have here make some sort of sense. And so what we're going to do over here is put in 0x100 and hit enter. And as soon as we do that, we should be able to see all of these codes. So there's our 451802, 451802, there's our stuff there, and this is what it's mentioning in the lab. Now this stuff that we have here at the start is disabling our computer operating properly circuit. That's all this stuff here. In C, that's SOPT_COPE equals 0 generates all this code, and we'll take a little look at that maybe a little bit later. And here's the important thing. So let's go back and take a look at, sorry, hit the wrong button. Let's go back and take a look at what we've got here. So there's all our codes in here. This is what it's got in chapter 1. This is exactly what you should have in at this point. And let's go back and take a look at Lab 3. And it said you should see this, and that's what we've seen in the assembly screen. And what we want to do at this point is we want to execute these codes. And what we want to do that is we want to set this up so our program counter, as it mentions here, is going to change from C007 to 100. So let's go and see how we go about making that happen. So if we look up here under core registers, and under core registers we have all of our CPU registers here. And there's the accumulator, there's H and X, program counter, stack pointer, and so on. This is the one here we want to change, and if you just click on it, we can put in 0x100. As soon as you hit enter, some interesting things are going to happen. If we back up just a little bit here, we can see that over here it says that no source is available because right now everything has been set up to work at C000, and we've now changed this to be not C00 but 100. And all we did to do that is change the program counter to 100 in hex. And the program counter basically says here's where your code is going to start. Now why did we do all this stuff? Well, we cannot use the Codewarrior memory browser to put in codes into Flash. That would be nice, but it doesn't allow us to do that as we saw in the last video. What we have to do is put them in here, punch in hex codes, and this is what we used to do in the old days. We actually used to use a hex keypad, punch all these codes in. We didn't even have a disassembler or an assembler. We had to work at this level, and just by punching these codes in, it disassembles and gives us all this. Now this is the most critical part of this. After we've enabled or disabled the computer operating properly circuit here, let me just move this up a little bit. So we want to load 12. What is 12? 12 is actually our switches over here. The lower 8 switches are address 12. In hex, this is address 11, as well as our 3 push buttons here, as we talked about last time. So it's going to grab the switches and store it to 0D, which is one of the LEDs, store it to 0A, store it to 1, which is a left 7-segment display. And so these are our 4 7-segment displays being stored to, and then it's going to go back to address 107 and just keep repeating that process. And the upshot of this is connecting the LEDs and the 7-segment displays to the switches by running this little program. Now right now, how do we run the program? Let's take a look, and it mentions that in the lab, is we can go up here. There's a couple ways to do it, and we're going to trace a little bit first. I just want you to see this. Now, if you're tracing something over here, you should have link with active debug context turned on. And you've got a couple ways here. This is the one we're going to use, step into. Now, if we watch over here, let me just slide over just a wee bit, and we can see these numbers changing. So if we step into, the first thing it's going to do is that when it loads here, HX with 1802, H gets the 18 and O2 gets this. Let's take a look and see what that looks like in terms of chapter 1 here. Now this is our CPU, and the concept that we have here with the CPU is we have data registers, and we only have really one data register, ACC or accumulator, for dealing with data values. But we have a 16-bit register made up of H and X, which deals with pointer values. And that's what we got here. That's why it's loading H and X with a 16-bit number to set a pointer to a particular address. Now the program counter that we looked at sets it to 100. It says there's where your code sits, and normally it's going to set it to flash because that's where everything's automated, but we're sort of going around all this automation stuff and doing things the way we used to in the old days. So what all this does here, and we'll trace through, it says load the value at the pointer. So let's take a look up here and see what happens here. Now as we start tracing, let's trace a little bit more. If we trace, we can see that the value at the pointer is D3. That's what it's saying here. Load A with the value at the pointer. The pointer is at this address, so 1802 had the value D3. And what it's doing now is it's adding that with 7F to get rid of the most significant bit. It's 53 now. And then it's storing that back. And what is this doing by putting a 53 instead of a D3 into address 1802? It's disabled the computer operating properly circuit. And that's all we really care about. Now, at this point, what we're going to do is start tracing through our code. And let's take a look. Let's step into. So right now, before we start, let's take a look. We've got the switches set at 10, 10, 10, 10, which is AA. So let's trace and see what happens when we load. Notice up here we've got the AA, and that came in physically from our switches here. So it read our switches. Now, do you remember what address 0D is? Let's take a look and see. Was it the red LEDs or the green LEDs? Well, let's trace and see. It was the green LEDs. So there's our value of AA going there. The next thing it's going to do is put that value here. Then it's going to put that value on our 4 7-segment displays. And when it's finished, it's going to go back up and trace back up to here to load the switches again. And that's what this program does in an infinite loop. What we can do at this point is just hit our resume button. And if we do that, changing these switches can change it to any value we want. So the switches are going to our LEDs and our 7-segment displays. If I happen to punch in a 1001, look at that, I've got an H. And remember 90 put up an H, and that's exactly what we have here. That's your first initial. And once you get to this point, this is actually going to be a very similar exercise as what is on your first lab test. And so as we go through this, just punching in a number to put on your 7-segment displays, given the addresses, that will be one of the questions on your first lab test. The second question will be this, punching in a bunch of hex codes into memory and being able to run it and see something happening. That'll be another 3 marks. Okay, once you've gotten your first initial, the next thing to do is take a look at what we have to do next. It says enter the following C program into Codewarrior, and it said remember to select C and minimum startup. Now the simple way to do this to save time is to actually just highlight everything in the code down to here. And if we do that and we say right mouse click and copy, we can copy that right into Codewarrior. So let's take a look at Codewarrior. And we want to go back here to C, and we're just going to click in here and do a Control A, Control V. And notice that it's sort of done everything right now. It's grabbed a little bit too much, which is fine. Let's bring this up full screen and take a look at what's going on here. Now it's got title, and this is kind of messed up a bit. We're going to have to sort of clean it up a little bit here. Author, your name, like so. Date, today's date. So it's kind of messed up a little bit, but it saves a lot of typing if you just do a little bit of cleanup here. And so let me just give you an example of how this should look. And let's tab this over here. And unsigned char. Okay, so this comment should be on this line. Let's just do all the cleanup here. And each one of these comments should be on the previous line. So we'll just, bring these up here to make it a little bit easier to follow. But basically everything that you need is fine. The only thing that's going to be a problem, and you'll notice over here if we take a closer look, there's a question mark. And it says, if we actually hover over the question mark, it says invalid preprocessor directive. Because one of the problems that you're going to run into when you copy from an Adobe file is it screws up the double quotes. We actually have to go in and type in proper double quotes both at the start and at the end. Now if we've got that in, let's fill in the programmer's block properly, because you should get comfortable doing this. So my first C program, that's fine. You should type in your name. Now don't type my name, type your name. And your student ID, usually it's 3 digits, dash 3 digits, dash 3 digits. And your course and your course lab section, MCO455, and type A if you're A, type B if you're B, type C if you're C. I'm going to put in Z in case we got a lot of groups, and put in whatever today's date is, and you're pretty much ready to go. Now let's just back out again, and if you remember how we do the compile, we have to double click on this, and then we're going to say project, build project. And it says here it's been modified, you want to save the changes, and we'll say yes. And it's going to run in the background, and if there's any problems, as we saw before, it's going to say something down here. Now notice it says an attempt to build a project has been made, the application file is already in use, so we're going to say terminate and build, because we don't care about what happened before. So we're going to terminate and build and continue on. So it should build this thing, and as long as we don't see anything here in the problem section when it's finished, everything should be good to go, and yay, we're good to go. So right now, if we look up here again, it's got our binaries all set to go, everything seems good. So we're just going to go, and we're going to go to the thing here, debug as we've done in the past, whoops, Codewarrior, and we're going to, in this case, go to the real deal. So if we click on this and hit OK, we should be able to run our program and just see what happens here. So right now it's ready to switch over. We're here, and instead of doing what we did before and doing something at address 100, we don't really care. We're going to run this program, but notice, isn't it interesting, if we just zoom in a little bit here, these look like pretty much the same codes as we had before, but these are now at C007 and so forth. And that's pretty much exactly the same as we had before with this load and so on, but instead of coming from a bunch of hex codes, it's come from this program here, where SOPT_COPE is actually these first 4 lines of assembly code. The rest here, value equals SWL, load A with 12, store A to that, it's doing exactly the same thing by creating this C program. So this C program has actually created exactly the same hex code or assembly code as we had before. Now if we want to take a look and use the memory browser, we can say 0xC007, and let's take a look at what we have over here. So let's slide over, and isn't that exactly the same code pretty much as you had before? Actually, let's take, so there's 451802, F6A4, so pretty much everything is in here as we had before. There's the B612, B70A, B7, so everything is pretty much the same. So what we're going to do is we're going to go up here and we're just going to run it. And if we run it, if we start flipping switches, we should see everything changes exactly what we did before. Now this is almost fun stuff, and you can get just about any pattern you want. But let's see what else is coming up that we need to worry about here on this lab. And it says run the program and get everything working. So that's all you have to do to get this. A high from the switches. So if we turn a switch up, let's turn them all on. What happens when we turn the switches up? It turns on the LEDs, but it shuts off all the 7-segment displays. So a high turns the switches on, turns on the LEDs, and turns off the 7-segment displays. Which CPU register is used to do all this business? Let's take a look back here. Which CPU register is being used? How do we figure that out? Let's take a look at disassembling our code again at address. In this case, whoops, we have to stop our code first. Let's stop. Let's take a look back here, and it's terminated. And if it terminates, here's the thing that you have to worry about. So if it's terminate, can we just run it again? Not really. What we have to do is, let's try run. We can say resume or whatever. We can say just debug. Let's try debug. And it's going to do some stuff here, and then we should be able to run it again. Here we go. It's all set, ready to go. So if we take a look here, and here's our context again. Let's go back and take a look at our lab. It says which CPU register is used to get the switch value. Let's take a look back here. Value equals SWL. Let's trace. Let's do that tracing that we did before. Step into. So now it's down here. Value equals SWL is actually the load A 0x12. So the accumulator A, and if we look up here in the core registers, that is what this A up here is. That is that accumulator A that we were talking about before. So that is how this works. Let's go back and take a look. And it says try out various switch combinations to fill this chart in. This would be 0x03 and so on. Fill all these in. And it says to make sure that these, if it's an odd number, make it an even number, and that's your next initial. Now there's some questions here that it says for the minimum startup, what value is placed into the stack pointer register. So let's take a look back at Codewarrior and see if we can find out what's going on here. When it does our initial startup, let's look at our core registers again. And the stack pointer, let's slide this down a little bit and then we'll zoom in so we can actually see it a little better. Let's grab this, slide it down. So our stack pointer, if we want to zoom in up here, our stack pointer is set to 87F. And that's the top of RAM. That's where things are going to be put into memory if we have variables. So let's see what else we have to answer in here. What is the equivalent assembly language instruction for value equals SWL? Let's take a look again. Let's just keep tracing down until we get here. SWL, value equals SWL is actually load A 0x12. What are the hex codes for that? B612. And that's pretty much all you need for here. Now the only thing you have to do at this point is to rewrite the C program so it uses a function to do this stuff instead of actually just running the main. And if you remember how this works, let's take a look. Let's go back to our C program and let's go back to C++ from here. And let's go full screen so we can see how this happens. Now we've got a couple neat features in here. If we zoom in here up near the top, you'll see that there's something called code folding. So if we click on this, we can fold that up, we can hit plus and it goes back, which is kind of cool. But what we want to do is we want to turn this into a function and not just have it as a main line. So here's what we're going to do. We're going to take everything that's in the for loop. Let's grab all of this stuff here and we're going to control X. And then after our main loop here, we're going to control V, put it all in here. So we're taking all this code out. Now let me just move this over a little bit. Tab this over, tab this over, tab this over. So we can see here's our for loop in here. And it says to make it something called update. Now what we have to do first is to put in a functions. First of all, let's add some stuff here. We can say that this is our includes section. Down here after this, we're going to put in our function prototype section. And the only function prototype we have, and if you look this up, it's going to be void. And what were we going to call this? Let's take a look again at our code. Update. Let's go back. Void, update, void. And we need to have a semicolon in here. And so that's what this code is going to be. Now what we're going to do is we're just going to grab this up to, but not the semicolon, Control C, drop down here, Control V, paste that in, and then put a bracket at the start, put a bracket at the end, and notice that little question mark went away. And then what we have to do is actually do a function call in here. So let's just tab over a couple times, put in update, bracket, bracket, and assuming that works, let's go back and double click here. Let's see if we have any problems if we do a project build. So we're going to save our changes, run it in the background, whatever, and if it comes up clean, then, and we're just going to say terminate and build, because we don't care about what was happening on before. We want to get an initial for this one. And when it's finished, we should be able to, oh, we got an error. Let's see what the error is. Declared, I see. Now, can you spot what the error is? Let's take a look and see. Notice we've got, and it even highlights it over here. If we zoom in a little bit, it's telling us here, value not declared or type name if you just hover over it. And why is that? Because we had it defined up here, which is useless to us now. Let's Control X. Let's put that definition in here. And again, let's go back and double click here. And let's try building that again. Build project and say yes. And let's see if it's going to come up clean this time. So you can very quickly see errors, but it's very easy to change a mainline program and just take all of that, put it somewhere after there, and just replace it with a function. See, it's working. Now let's take a look at running this up. We debug as Codewarrior, just like we did before. We're going to use the real deal, and we're going to say OK. And let's just see if this is going to run the same as the other one, because that's your last initial if you can get this working. So we're ready to go. And instead of having anything fancy to trace or anything, what we're going to do is we're just going to come right up to the top here, and we're going to hit the resume button. So if we resume and everything is working like this with our new code, we have our completion of Lab3 done, and that is going to be the last initial that you need here. So once we do that, that's your last initial. Lab3 is now complete.